In a previous video, I got this new boiler installed, which is the Viessmann Vitodens 050W, and I got it installed by Heatable. So I made a video on that, you can check it out, I'll put a little card up, and I was very happy with it. And in that video I mentioned that while I was just going for the standard basic wireless programmer that Heatable provide at the time of ordering, I was going to replace it with a Nest thermostat further down the line. Well, Heatable saw that video and got in touch and asked me if I wanted to get one, so they've sent me this over. So massive shout out to Heatable for sending this over. They just gave me this to make a video on it. And obviously they've not paid me or anything and they've not really told me anything to say in this video. But if you are interested in getting a boiler, Heatable was pretty good, and I've put a link in the description and a discount code for your new boiler from Heatable. But yeah, they sent this over for me to install. So my plan for this video is to provide quite an in-depth installation guide for installing a Nest. This video will also be specific to the UK and possibly Europe. The Nest in America is a very different sort of wiring setup. So this is the sort of wiring setup you'll find in the UK, and it'll maybe be similar to Europe, but obviously a bit different. So I'll be going into a lot of detail. I'll be installing this first of all for basic on-off control. Then I'll be installing it for OpenTherm, so we can take a look at both of those ways of controlling a boiler and using it with a thermostat. At the start, I'll be installing it on this stand, which just lets you plug it into the mains. And later on in the video, we'll hardwire the thermostat so it's mounted on the wall and hardwired back to the boiler. So we'll basically take a look at all the sorts of different ways of installing a Nest. There's a few different ways you can do it, and we'll take a look at all of them in this video. Now obviously that means it's going to be a very long video. So if you're interested in particular parts of it, I've put some chapters in the video description and also on the video seek bar. So you can use those to skip to the parts that you're interested in. Now as to sort of set expectations, the sort of level of knowledge I'll be assuming with this is someone who at least is confident with wiring and knows basics about boiler controls. If you've got absolutely no knowledge at all and you've literally never picked up a screwdriver in your life, I probably wouldn't recommend following this video and trying this. At that point, you're probably better getting a professional in. And at any point, if you find that you're stuck or struggling or out of your depth, get someone in. Paying someone £100 or so to come and fit a Nest is going to be a lot cheaper than replacing your boiler because you wire something wrong and accidentally kill your boiler. So only do this if you're definitely competent and you know what you're doing. So yeah, if you're following this video, do not treat it as a guide in the sense of just like copying exactly what I'm doing. Make sure you have enough knowledge of how your system works. And especially if you're following this video, don't treat it as a sort of guide where you just copy exactly what I'm doing. Don't just go, oh, he put the grey wire here and the black wire here, therefore I'll do the same. If you do that, you're running the risk of causing a lot of problems. You really need to understand what the individual wires in your system do and how your system's controlled, and then work off of that knowledge, not just blindly copy exactly what I'm doing. So yeah, if in doubt, you're going to need to do a lot more research or just get a professional in. Additionally, it's worth mentioning that I have a combi boiler, so I'll be wiring this up for a combi. Presume most people know what a combi is, but basically a combi boiler doesn't have a separate hot water cylinder, it heats hot water on demand. So all the Nest will be doing is controlling the heating. It'll be turning the boiler on and off for the heating. It won't have any control over the hot water. If you have a system with a separate hot water cylinder, be it a heat-only boiler or a system boiler, you will then need to also wire that up to the Nest. Obviously I don't have that system, so I won't be covering that in this video, but when we open up the heat link, I'll take a look at how you would connect up your hot water system, so how you'd kind of connect it into the heat link, but I won't be able to go into a huge amount of detail. Especially if you have a system like that, bear in mind that they are very complicated and you need to get it all right. So if you don't understand how your system works, I would definitely recommend checking out John Ward's videos. He's done a few really good videos. I'll try and put a card up or put a link in the description about all the different ways that heating systems can be wired in the UK. So S-plan, Y-plan, potentially he's got videos on gravity fed, I'm not sure. But those videos really explain in detail how a heating system's wired, especially if you've got a hot water cylinder. And if you're going to attempt to install a Nest with a system like that, make sure you've watched those videos and identified first of all what type of system you have. Is it a Y-plan, is it S-plan, is it gravity fed? And then only once you've done that and you know exactly what your system type is and how it's wired, would I then recommend attempting this. With a combi, it's relatively simple as you'll see, but if you've got a system with a hot water cylinder, it gets a little bit more complicated. So essentially the long and short of it is that this video is not intended as a full-on tutorial. This is a very DIY friendly project, but only if you really know what you're doing. So if at any point you have any doubts about what you're doing, do not proceed and just get a professional in. And I'm obviously not responsible if you try this and you blow your boiler up. You've been warned. Make sure you know what you're doing before you try it or get someone in to do it. But yeah, with that warning out of the way, what we'll now do is we'll pop in, take a look at the hardware, we'll unbox the Nest, take a look at it all, and then we'll get it installed. So first of all, we'll unbox the hardware. So here we can see there's two different products, and these are actually things you would buy separately. We have the Nest Thermostat kit, and then we have the separate stand. Now, if you're installing a Nest, you absolutely need the thermostat, obviously. And this contains the thermostat, the heat link, and the base that you'd mount to a wall. But with this kit here, the expectation is that you mount your thermostat on a wall and wire it back to the heat link, which is the little receiver that connects next to the boiler. We'll take a look at that later. So to use that, you basically need to have some sort of existing thermostat wiring in your wall. Really, some sort of cable that goes from your boiler to wherever you want the thermostat. And that already needs to be in place, or you would need to run that. Alternatively, you can buy the stand, so you need to buy this separately. And what this lets you do is take the thermostat, mount it onto the stand, and this also comes with a power supply, so you can just plug the thermostat into the wall. So if you don't already have thermostat wiring, or you want the thermostat located somewhere that you don't have that wiring, you know, if the wiring goes to wherever a place that you don't really want the thermostat, then you need to buy this stand separately to be able to power the Nest up and keep it separate on its little stand. We'll take a look at both of these. Now, personally, I'll probably actually just hardwire it because I've already got wiring to a place that I do kind of want to put the thermostat, and I'd rather just have it wired in and then I don't have to worry about sockets and having this sitting somewhere. But we'll take a look at the stand as well because this might be quite useful for a lot of people. And if you're interested in buying any of these parts, I'll also put some links in the description and a pinned comment. So first of all, we'll take a look at the thermostat itself because that's the more useful part, the bit you actually need. So this is here. Obviously, this is the 3rd generation learning thermostat. They also do the Nest E. That's a totally different product. It's very similar, but it doesn't have all the learning features and it's designed for much easier DIY install, whereas this is the more full-featured version. It's available in a few finishes. This is a stainless steel one. I think they also do white, black, and a copper type one, but yeah, stainless steel is one I like as well. And yes, that's the box there. Basic stuff about Google Control, some pictures, some more pictures. So yeah, let's get this out. So we'll unbox this and we'll take a look at the hardware it includes. Should have brought a knife over, that would have been a lot smarter, but I'm sure I can manage it. There we go. So let's get into this. And this is actually one of the first times I've ever used a Nest. I've seen them installed in people's houses and things, but I've never actually used one myself. So yep, now we can open this up. So it's got this little seal here. Google Nest Learning Thermostat should be installed by a professional. Well, I'm a professional idiot, so that'll probably do the job. So yeah, I'll take this out, break that seal, and take a look. So yeah, interested to see what this is like. So get this out here. And yeah, for people wondering why I've gone for Nest and not some sort of other DIY type solution or various other options, we'll go into the OpenTherm control later in the video, but basically Nest seems to have, at least to me, the most mature OpenTherm implementation. And what I really wanted with this was all the really good OpenTherm modulating control. So I thought I'll go for Nest. I can still integrate it with my smart home using Home Assistant and stuff like that, but at least this will give me really good modulating controls, because while I love having nice sort of obscure locally hosted stuff that doesn't rely on the cloud, realistically energy savings are more important than that for me, so we'll go for this. So yeah, take that out, and that's the thermostat there. So that is extremely shiny. Oh, it's got a bit of plastic over it, that's why it looks weird. There we go. So that comes off, and that's the thermostat itself. Pretty heavy. Yes, that's it there. Feels quite nice. So that's the first time I've ever really seen one. Looks pretty good. And on the back, you've also got where it'll connect onto its little base and a USB connector. I presume that's some way to power it. Maybe if it's on a stand, maybe you power it over USB, or maybe it's like a firmware update. I don't know. I'm guessing, but that's the Nest itself. As for accessories, you get this, which is presumably some sort of paperwork and manuals. Yeah, it's just paperwork and manuals, so I'll not need that, or I probably should look at that. Then here you have the heat link. We'll take a look at some more detail later. I'll get all the parts out, then we'll take a look at it all. This is the part you put next to your boiler and wire in, and then this talks wirelessly to the thermostat. And then under here you get this, which is the thermostat base. So this is basically the thing you mount on your wall and you mount the thermostat to it. So yeah, that's the thermostat base there. So yep, that's that. And then finally you just get a set of screws. These are just pretty coarse threads. They're just screws you'll also use to mount the stuff if you want to use these, or you can use your own screws if you're mounting to a different type of surface. So that's what you get there. And oh, one more thing that I forgot about. This is what they call a trim plate. And this is quite a neat idea. Essentially, all it is a big bit of plastic you mount the thermostat to. So normally when you're mounting the thermostat, you just mount this base to the wall. But if you say taken your old programmer off and you found that, like, say someone's painted around it, not painted behind it, or the wall's just a bit damaged, or there's like screw holes in the wall and you don't want to fill them, what you can do is you can mount this behind the thermostat. So the thermostat will mount onto this and mount that assembly to the wall. And literally this bit of plastic just kind of covers up bits of the wall and hides some of the damage. Ultimately, I'll probably mount this really neatly to the plasterboard and try and fill the wall in so it's just this on the wall with nothing around it. But given I've already got a big back box and some holes in the wall for the existing programmer, this could be quite neat. So we'll take a look at this as well. So yeah, that's the parts you get there. So what we'll now do is we'll take a look at the stand. Next up we have the stand, so we'll take this out as well. And we'll see what you get. So this is basically just if you want to mount it on a stand and plug it into the wall rather than hardwiring it, you can do that. Although we'll take a look later, I've just realised that you can seem to plug USB into this, so you could probably wall mount it and wire this into USB if you wanted to then power it without having to necessarily hardwire a cable all the way from your boiler to it, which is nice. But yeah, the stand's probably quite a neat option for a lot of people if you just want to be able to have it sitting on a shelf or on a table. So yeah, this is quite nice. So take a look at this. And yeah, this is sold separately, and I think it's about £30, which is quite steep. There are a few aftermarket options I've seen, but I don't know how good they are, but not deadly. So yeah. This is the stand here, so we'll see how we get this out. That's that. So in here we get power brick. So this is it's literally just a USB power brick. Tiny little thing. Little instructions. Cardboard. There's the stand itself. Now that actually feels really nice. Like, it's expensive for what it is, but that is actually really nicely weighted, which is quite cool. So it's got quite a lot of weight to it, which is nice. And that's what you do kind of want. Especially with it being wired into the mains, you don't want something super light that's going to float around if you tug on the cable or move something near it. It's going to like tug the cable and pull that across the surface. That actually feels quite solid, and then it's got this sort of slightly grippy base. So I think if you actually put that on the table, that's not going to slide around if the cable gets tugged, which is good. And then finally in here, you're going to get what I almost always certainly expect will just be a micro USB cable. Yeah, that's all it is. So you just get a pretty nice quality actually, but just a standard micro USB to USB type A cable. So yeah, all you'll do is you put the thermostat on this, you then wire the USB cable into the back of the thermostat, and then you plug that in. Right, I'm trying to think, do you actually put this on here? Yeah, I think you do actually. Yeah, so I think it looks like you actually clip the base onto that, and then you put the thermostat on that and USB into it, I think. I would just really read the instructions because right now I am literally just guessing, but yeah, I think you have to, you mount that onto there and then thermostat onto that. So yeah, that's the stand there. We'll take a look at this later. What I'll do is I'll do the initial setup with it on the base, and then at the end of the video I'll do a separate section where I then hardwire it, so you can kind of see both ways of doing it. But yeah, that's all the hardware there. So what we'll now quickly do is we'll take a look at this heat link, just to see the wiring inside it, just to give a very rough explanation of how it works, and then we'll look into getting it installed. So the first part I want to take a look at is the heat link, because seeing this will then really sort of help you figure out how you're going to wire it in. And essentially what this is a wireless receiver that connects to your boiler. So you can plug this, you wire this up into your boiler, either replacing your existing thermostat or programmer, or if you've got an existing wireless receiver for your existing programmer like I have here, you'd be replacing your wireless receiver with this one. And this wires into your boiler, into power, all that sort of stuff. And then this talks wirelessly to the thermostat itself, which is installed in the room you want to measure the temperature in. So yeah, that's what this is here. So if you open this up, there's a little screw on the bottom. You can see there's loads of space at the bottom to bring wires into it as well. And if you lift that off, you can see the wiring. So yeah, what you can do is you can either bring your cables into the bottom of it here, using these nice cord grips, so you can use these tightened down onto the flexes to keep them in place. Or you can see here at the back, there's these slight little ovals. Essentially what you do with these is drill them out if you want to bring the cables in the back. So what you could do is you could drill holes through that, bring the cables through the wall into this from behind, and you wouldn't have any cables on show. So that's really a really neat way of doing it. I think for me, because my boiler's already boxed in, and I'll be installing this inside that boxing in, I'll just wire it in directly into the bottom here, just to make it very easy to access all the cables. And what I'll now do is we'll talk about the wiring that's in here. So as you can see, there's a big row of connections or terminals at the bottom, but you won't necessarily need all of these. It really depends on your existing wiring. And actually, if I bring the lid in, the lid actually explains this wiring in a bit more detail. So what we'll do is we'll take a look at what this all means. So on the left here, you have neutral and live. That's just a permanent neutral and live supply, and that's purely to power this up. So basically you need to have a permanent live and neutral main supply into this just to power the heat link up. Then you have terminals 1, 2, 3 and 4, 5, 6. These are a pair of relays as they're described here. So the left one is for heating and the right one is for hot water. And essentially these relays will turn your hot water on and off and your heating on and off. So we'll look at this in more detail when we actually take the existing programmer apart. But essentially what you have is these two relays, which are, if you don't know what a relay is, well, you should probably get someone in. But if you don't know what a relay is, essentially it's an electronic switch. So essentially this will just switch itself on and off based on the timer set through Nest. So what this little graphic here shows is that normally, if you have that middle contact there, that's called common. And normally when this Nest is not wanting to switch the heating on, it is switched so that the middle contact is connected to terminal 1 here, and the middle contact on 5 is connected to 4. And then when you turn on your heating, that will switch over to here. So instead it'll connect 2 to 3. And if you switch on the hot water, it'll connect 5 to 6, so that little switch will switch over. And that's essentially what you'd have here. On your existing program, you'll have some sort of wiring that will be going into a switch contact, and you'll wire these into these two terminals here. So we'll talk about this in more detail. It'll make more sense when I take my existing programmer off. But essentially what you've got here is the two terminals, which are for the two relays for the hot water and the heating. Next up over here, you see these two terminals, which are labelled OT1 and OT2. These are for OpenTherm, and that's ultimately what I'll end up using. I'll initially connect this up for on-off control using the relay, but then I'll switch over to using OpenTherm. Now what OpenTherm is a modern standard for controlling boilers. So whereas with these relay contacts, it's just simple on-off control. When you turn your heating on, this switches on and it tells your boiler to turn on. And when your heating is to turn off, this switches back again and your boiler turns off. That's all it can do. All the Nest can do is turn your boiler on and off. And when your boiler's pumping water around the radiators, the temperature of that water is just the temperature that you set on the front of the boiler on your boiler's control panel. OpenTherm is a lot smarter, and we'll take a look at that. Where what this is a digital connection between the Nest and the boiler. So the two devices can talk to each other. So rather than the Nest saying to your boiler, turn on, turn off, the Nest can actually say to your boiler, right, turn on and set the water flow temperature to 40 degrees. Or turn on set the water flow temperature to 50. Or if the room's really cold and needs to be heated up quickly, the Nest can go, right, turn the water temperature up to 70 or 80 degrees. And what that means is the Nest can measure the temperature in the room and tell the boiler, and it can be in communication with the boiler to work out the best temperature of water to put through the radiators. And this is very good for efficiency. Essentially what it means is that the water going through your radiators will be dissipating most of its heat into the room, so the water going back to the boiler will be cooler. And that allows the boiler to condense, which means it's more efficient. There's a much better video than that, I'll put a link to. But essentially with OpenTherm you get much better efficiency. The other benefit that I'm really excited to see is where, because the water going through radiators is now at a much lower temperature, the boiler runs for longer, but at a much lower power level. So rather than having the boiler turn on, blast heat into the room, and then turn off again when it gets too hot, and then wait for a while, and then turn on again when it gets too cold and blast heat into the room, what should happen with using OpenTherm is that the boiler should run for much longer. It should stay on almost most of the time, but just firing at a very low level. So it's not going to use as much gas doing that because it's running at a much lower level. Ultimately, you probably won't save too much gas because it's running for longer, but it's not like it uses much more gas. But it just means that rather than having those huge temperature fluctuations you'll feel when the boiler turns on and off, it'll just sit at a very low level, keeping the room at a nice temperature. So the temperature should be a lot more consistent, which is good. Additionally, because the boiler isn't turning on and off constantly, and it's not heating up and cooling down constantly, it should be a lot less wear on the system, so it should protect the lifespan. So yeah, that's what OpenTherm is there. Later when I install it, I'll talk about this and probably repeat myself again and explain all that again, but yeah, that's what OpenTherm is there. Finally, you have this connection here, which is labelled T1, T2 and earth. Now, as I mentioned, the thermostat needs power, but you can wire it back to the heat link, and that's what these terminals are for here. What you can do is run a cable from T1 and T2 in this, and run it all the way over to the base that the thermostat's mounted on, and wire it into these two terminals here. And what that does is power the Nest thermostat from the heat link. So I'll be doing that later in this video, where what I'll be doing is I'll be reusing the existing thermostat wiring that's been installed in my flat since it was built to feed a 12 volt power supply from this heat link over to the Nest installed in the hallway. And this just means that you can power your Nest up without having to plug it into a socket, so you don't need to waste any sockets, you can just have it powered from this. So that's all these are there, just that 12 volt connection. So yeah, we'll take a look at all this wiring later, but yeah, that's roughly how it works. You've got your neutral and live in to power the heat link, your relay contacts for heating, relay contacts for hot water, OpenTherm connections, and then 12 volts out to your your thermostat if you want to use that. And what does look quite good here is that there's loads of space in here for wiring. It's not really come across when I've looked at pictures of it, but what you can see is it's actually quite thick, so that's really good. You can probably get quite a bit of slack in there looped in, so you're not having to cut the wire super short. So we'll take a look at how to do the wiring neatly later, but there's quite a lot of space in here, which is nice, so you're not going to have to cram wires in, which is definitely pretty good. And that top will just clip on like that, which is pretty neat. And then there's a couple of LEDs in it that I presume will just shine through the top, so I think when you turn hot water on, or turn heating on, that comes on. When you turn hot water on, that comes on. Of course, in my setup, I'll just be using it for heating, I won't be using it for hot water, but it can do both. And that's one thing that's quite nice with Nest over, say, Hive, is with Hive, you have to buy a specific hot water capable version. With Nest, it's just hot water capable out of the box, and you can just choose not to use it. So yeah, that's a look at the heat link. What we'll now do is we'll go over to the boiler and take a look at the existing controls and work out how we're going to replace them with this Nest heat link. So first of all, let's take a look at what we have currently. So here we have the boiler, which is a Viessmann Vitodens 050W. And I'm just using the standard EPH controls that Heatable provided, which I think is the CP4, I think that's model number. So the way this is basically wired is under here we can see we have this receiver. It's a wireless system, so there's a thermostat mounted in the hallway, but that's just wireless and battery powered, and that comes back to this receiver here. We'll take this off in a second, but that receiver is connected with a 5-core flex that goes through the wall and up into the bottom of the boiler. And that's currently just wired up for on-off control. So all that'll do is just switch contacts to turn the boiler on and off. It doesn't do any sort of modulating OpenTherm type stuff currently. To power the boiler, it's fed through this spur here, and there's just a bit twin earth that comes through the wall into this flex outlet plate, and that flex just connects to the boiler. All that is just a 3-core flex, and all that does is power the boiler. The final thing you'll see is we have this flex here that's all coiled up, and this is for OpenTherm. When I had the original install done, the guy was just connecting it up for on-off control and didn't really seem to understand OpenTherm. So rather than trying to confuse him and trying to get him to connect this up for OpenTherm, I just said, right, if I give you a bit of flex, can you wire that to the inside of the boiler and just leave it coiled up in this junction box? So it means that I can connect up OpenTherm without having to actually take the boiler apart and go into the wiring. So what this is currently is just literally a 2-core flex with a pair of Wagos in that junction box, and that's just the OpenTherm connection. So that just takes the OpenTherm connection inside the boiler and breaks it out to the outside. So as I mentioned, we'll be installing this for on-off control initially, and then later in the video we'll convert over to OpenTherm. So at the point that we convert to OpenTherm, we'll be using this flex here to connect it up. So that's what that is. That's the OpenTherm flex. So what we'll now do is we'll get all the power isolated and take some of these fronts off. So we'll take the controller off, we'll take the spur off, and just take a look at what wiring we have to work with. So yep, time to go and do that. Now, obviously if you're doing that, you need to make sure you safely isolate it all. Don't just trust switching the spur off, for example. Be careful. You make sure you've got a proper tester. You can test things are dead. There's good videos on YouTube. I think GSH Electrical have a lot of good ones about how to prove dead and do safe isolation. Do that because you don't want to sort of blow yourself up. Because, for example, if you turn the spur off here, which I will do, that'll turn off power to the boiler and everything. But if I then take the spur off the wall, well, it'll be live behind here still because I've just switched it off. So here in my case, I can turn off the heating circuit and that'll turn off the power to this spur. On the other hand, your spur may be spurred off the socket circuit. It may not be on its own circuit, in which case you need to find the appropriate socket circuit and turn that off. But the problem with heating circuits and heating wiring is that often it's very sort of badly wired, or it's just been bodged over the years, and it's not unreasonable that someone might have wired something weirdly and cross-connected it onto another circuit and you're back-feeding power in a weird way. So look up how to do safe isolation if you're going to do this, and make sure that you test that everything is definitely dead before you work on it, because it can be very easy to think it's all turned off, turn off your heating circuit, turn off your spur, and find that someone's bodged something weird and actually there's part of it that's still live. So yeah, just be very safe, very careful. But yeah, I'm going to go and get that circuit isolated and take the fronts off. So now that everything's safely isolated, I've popped the covers off and we'll take a look at the current wiring. Now obviously bear in mind this will be very different to yours potentially, so don't try and copy this blindly, but I'll just sort of show and try and explain what I have here to give a rough idea of what I'm working with and the sort of thought process I'll go into when I'm wiring it all. So first of all, down here we have the spur, and this is where the boiler is powered from. So we have this twin and earth coming into the spur that carries power from the consumer unit, and then we have this twin and earth coming out the spur that goes off the boiler. So all this does is take that power, put an isolation switch, and also a 3 amp fuse to fuse it down. This twin and earth that comes out the spur then comes through the wall and comes into this flex outlet plate down here, and all that does is bring the twin earth out the wall and find a way to connect that flex on for the boiler. So this flex here that goes off the boiler essentially joined through here, and comes out here into the spur and then back up to the consumer unit. So that's all that really is. Then all the earths are just common together in a Wago. Then it's only in a Wago purely because this terminal connection is really a bit fiddly and a bit rubbish, so it's easier to put them all into there. Now you'll also notice this 3-core cable, and that's just sitting sort of blocked off in a Wago right now. This was used for the old programmer. So while this system now has a wireless receiver we'll take a look at in a second, with my old boiler I had a hardwired programmer, and that was mounted in the hallway. And that's what this cable's for. This is a 3-core earth that goes from here to the hallway where the old programmer used to be. And with the old boiler, this was then ultimately linked up through a bit of flex that came through out the wall and into the boiler. But it's now all disconnected. So if you've already got a wired programmer somewhere, say in your hallway, or a wired thermostat, you might have a situation like this as well, where you have a cable going from near your boiler, be it in your spur or wiring centre, somewhere like that, to the thermostat location. Now, when you're wiring a heat link, you will no longer want the switch live signals for the boiler going over that cable to the thermostat location because you're putting the heat link next to the boiler. So instead, you're going to have to work out where that join is, or that cable's joined, take the cable that's coming out the boiler and bring that into the heat link, and then you'll just have this cable that goes to your old thermostat location disconnected. But this is what we're going to use to power the Nest thermostat. So using that 12 volt output that's on the heat link, we'll actually connect that up to this 3-core earth, and this will run to the hallway carrying that 12 volts, and that'll power my thermostat when it's on the wall. So we'll take a look at that towards the end of the video, we'll do that part, but yeah, that's what this is here. It's basically a 3-core earth that's currently disconnected. But if you've currently got a wired thermostat in the hall, or somewhere in your house, you'd have the same cable potentially installed, but you then need to disconnect it yourself. But yeah, that's the system there. And then very quickly looking on the other end of it, here we have the new programmer on the wall, which is just that wireless one that Heatable provided. We can just pop that off. If you take that off the wall, you can see I've mounted it haphazardly to this back box, but that's purely just to keep it out of the way. If we attempt to unscrew this faceplate, which I'll just do off camera, we'll see what's behind it. So with that out of the way, this is what we're left with. And this was where the original programmer was. My old hardwire programmer was sitting on this Patras box here in the wall. With that all now removed, I still have this 3-core earth, and that's just the other end of that cable that's behind the spur, and again it's just sitting capped off in a Wago here. So this is where we'll be installing the Nest thermostat. We'll install it over this, and ultimately wire it into this towards the end of the video. So yeah, this sort of thing I'm sort of trying to get at, is if you've got an existing wireless receiver, you'll be doing exactly what I'm doing here. If you've got an existing hardwired thermostat, you'll need to find where the cable coming out the boiler joins onto the cable that goes through the walls of your wired thermostat, and instead take that cable, disconnect it, and run that cable into the heat link. So yeah, that's what I've got here. So that's the hallway, and we'll come back to this later. So now here we have my original wireless receiver. So we can take a look at the wiring in here. We have a permanent live and neutral to power it. So this is just a permanent live and neutral supply. It comes out the boiler, but it's just not switched at all. It's just literally a permanent live and neutral, and this just powers this receiver up. Sometimes if you've got a programmer somewhere sort of mounted centrally in your property, it might be battery powered, so it might not actually have a permanent live and neutral, but in this case I do. Then over here we have these 3 terminals here, which are the switch contacts. So this symbol up here kind of explains what it's like. When the heating is turned off, pin 2 is connected through to pin 1. And when the programmer wants to turn the heating on, instead pin 2 will then be switched over and it'll connect onto pin 3. So that's why we have these 2 wires here. They're connected between 2 and 3, and therefore when we want to turn the heating on, we connect these 2 wires together. And this is exactly the same as on the Nest heat link. So if we take the heat link and we pop it open and take a look at the wiring diagram on the inside of it, you'll find it's basically the same thing. You have this here, which is heating. It's a weird symbol, but that represents heating, and it's basically that same deal. Pins 1 and 2 are normally connected together, and pins 2 and 3 are not normally connected together. Now, it just so happens that the numbering between these 2 actually does match up, but I wouldn't necessarily trust the numbering. But you can see by the diagram here how it works. So we have the 2 switch contacts are going into the normally open contacts, the one that's not normally joined in. And it's the same here. So all we'll really need to do to connect the heat link for on-off control is basically just replicate this wiring using the heat link's wiring diagram. Now, if you've opened up your receiver and you've potentially got additional wires in here, it may be a case that you have hot water control as well, so you need to kind of look at the wiring diagram and figure out how all that works. And what you'll notice here is I have 2 switch wires and a permanent live and neutral. You may, on the other hand, find something slightly different, where you might have permanent live and neutral and a single wire that's used to switch it. Now in that situation, what it probably will be is that your programmer is potentially switching the permanent live to this. So essentially, it's switching the permanent live connection to your switch live, and you don't have the second live, because realistically, one of these switch contacts is exactly the same as this permanent live. They're essentially connected together inside the boiler. So yeah, you may find that you've actually only got one switch live. In that case, if your programmer just has a single connection for it, it may be a case that your programmer itself is switching the 230 volts mains to the output. In that case, on the heat link, what you then need to do is put a wire link between the permanent live here and the common on the relay. So you may need to do that if your existing receiver has 230 volt switching. This may especially be the case if you've got hot water control. With hot water control, you might have a similar layout, but instead of having two switch wires, what you'll actually have is permanent live, neutral. One of these will be a switch live for the hot water, and one of these will be a switch live for the heating. And in that case, what would happen is your receiver would be switching the permanent live between the hot water one and the heating one, depending on what it needs. And in that case, again, you're going to have to basically potentially put wire links between the live and the common on both relays, so between live and 2 and live and 5. If you're getting to that level, look at the wiring diagrams in the Nest manual. The manual has really good documentation explaining how to wire up for all sorts of different hot water control and all this sort of stuff. So yeah, this will the manual will explain it a lot more, but again, if you find you're out of your depth, get someone in to do it, because it can get quite complicated. But yeah, the wiring diagram does kind of explain it quite clearly how you're kind of to do that. But yeah, all we have here is a pair of switch wires and permanent live and neutral. So we just need to replicate that onto the heat link. So all I'll do is I'll get this off the wall, get the heat link mounted, and we'll get this wired up. Oh, and one more very quick thing to remember is once you've taken the front off all your sort of programmers and stuff, before you remove a single wire, take photos of literally everything, because it could absolutely save you down the line. Because what you can end up doing is say you take it all off the wall and then realise you're totally out of your depth. If you've at least got photos, you've got a sort of fighting chance of putting it back together how it was. Whereas if you just take it totally off the wall, end up with a bunch of wires sticking out the wall and have no idea what they do, you're then stuck without heating and potentially hot water until you can get someone in to sort it. So yeah, as soon as you sort of take the front off things, before you take a single wire out, take photos of everything. Okay, so that's the old programmer removed, and I've mounted the heat link, and then I've pulled the flex out of the wall where it was running through, and I've now got it here. And also I'll just fill those holes in afterwards, that'll be dead easy to do. So we'll now talk about wiring this. Now, as you can see, we have the flex here, and as you can see before, it has the permanent live, permanent neutral, and then the black and grey, which are the switched contacts. Now, you'll also see this cable does have an earth in it that's been cut off, and this is something that I'll kind of need to probably leave up to you really to sort of think about, is with this, the earth's been cut off, and I've tested this, and it doesn't seem to be actually be connected inside the boiler at all. I've also looked up the boiler, and it doesn't seem that this boiler really has an easy way to connect an earth inside it. It's all spade connectors, and then all the factory installed earth are just on spade connectors. There's no easy screw terminal just to connect that earth to. So I can see why they've kind of just cut it off. Because the original programmer itself is definitely class 2, so it'll have a little symbol inside it. If I can open it off camera. There we go. If you look at the original programmer here, you can see it has a little class 2 double insulated symbol, so this doesn't need an earth. Now the Nest gets a little bit more confusing, because on the Nest you can see it does have an earth terminal. If you look in there, right up there next to T1 and T2, there's a little earth terminal. And I can't see any sort of double insulated symbol on it. However, if you look in the manual, it's a little bit weird, because it doesn't mention connecting the earth just sort of in the normal instructions, and it is a fully plastic enclosure device. And if you look here in the manual, it says that there's T1 and T2, which is the connections to connect power to the thermostat, that 12 volts. And then for the earth, it says, if using T1 and T2, connect to earth. So to me, that seems like you don't need to necessarily earth the heat link if you're not using T1 and T2. But if you're connecting it to a remote thermostat using that DC connection, you do. And that feels a little bit weird, because why, if it's DC? All I can really think is if it's some sort of like interference suppression thing. Because obviously if you're extending the DC connection over a long distance of wire, could that potentially pick up interference and impart that interference on the power supply side of it or something, on the low voltage side of the power supply? Maybe. So maybe it's some interference reduction thing. I'm not quite sure. So in attempting to figure this out, I watched Big Clive's teardown of this. He did a teardown of these heat links. And I looked at it, and it seems as though that this, one of these T1, T2 connections is actually connected onto that earth internally. So we take a multimeter and we test between the earth terminal and the T1 which is next to it. Let's see what we get. It's hard to do in this position, but if we check that, we have continuity. So that says that actually T1 is connected to earth. So realistically, I would leave it up to you. Ideally, I would probably connect the earth up, irrespective of what you're doing. And if you're using T1 and T2 to feed power to a remote thermostat, you definitely need to earth it. But I'll leave it up to you. And if in doubt, if you don't have an earth available, you might want to then say contact Nest Support and see what they say. So in this setting here, set up here, because that earth obviously isn't actually connected, for now I'm not going to connect the earth when I'm doing on-off control here. Later in the video, when I connect up T1 and T2, I'll connect the earth at that point, because I'll be installing a 3-core flex to connect T1 and T2, and I'll use that to also connect the earth up. So I will be earthing this later on because I will be using T1 and T2. If you're not using T1 and T2 to power an external thermostat and you're running the thermostat on the stand, I'll leave it up to you to sort of judge whether you need that earth or not if you don't have one available. Obviously, if you have an earth available, just connect it. So yeah, we need to connect that into here. So we have these wires here to connect in, so all we're going to do is connect the live and the neutral into the live and neutral terminals here, and then the grey and the black, which is the switch contacts, I'll be connecting into the appropriate terminals on the hot water connections here. Sorry, the heating connections here, that's heating, that's hot water. So we're connecting these into the heating connections here, and then hot water we won't connect because it's a combi. So we'll need to cut these all to length, get them stripped and get them connected. Now, one thing I would recommend doing is, as you can see, these are all fine stranded flexes, so there's lots of individual very thin wires. And if you've ever worked with these are a pain because you push them into a connector or a terminal, and one wire will just kind of stray off the side like that. And that can be quite nasty because if you end up with one of them straying out and then one of the other ones strays out and they touch, then you create a short circuit and it blows up and all that sort of stuff. So what I would strongly recommend doing is investing in a set of ferrules. These are not expensive, you can get these on Amazon, I'll put a link in the description if I can remember. But all these are little plastic sort of based metal tubes. And what you do is you put these over the wires and it takes all those individual little strands and puts it into one solid little tube. And then you crimp it down with this crimper and it then gives you a solid piece of metal to put into the terminal. And that is so much more reliable. It's a much more professional feel, it looks a lot better as well. And it means that the screw screwing down onto that doesn't then mash the wires up and push them all out of shape. And then it means if you take them out again, put them back in, it's really easy to do. But it also stops all those like little stray wires sticking out. So I'll also be using these ferrules on the wires as well. So definitely recommend getting a set of these because these are so worth it. Oh, there's one wrong compartment there. There we go. So yeah, what I'll do is I'll get these all cut to the appropriate lengths, get the ferrules on them, and then we'll get them connected in. Okay, so now strip these back and put some ferrules on. So I've got one more to do that I thought I'll do it on camera. And then we'll get it in. So with these ferrules, all you do, it's going to be quite hard to do because it's a very big camera and it's very in the way, but basically get all the wires neatly like that. Find the right size ferrule, you need to match the size of the ferrule to the size of the flex you're using. Carefully put it over, making sure you don't end up with any stray wires coming out the back here, like that. Once it's pushed all the way in, find your ferrule seal, there it is, and just basically feed it through the middle there, crimp that down, and there we go. That's now on the wire, and that's very solid, that won't pull off, and that's now on there. Now what I tend to do with ferrules is I tend to let the copper stick out the end, and then I come in afterwards and snip off the very last end of it, and that kind of gets rid of that. Because this is normally too long for the terminal anyway, so cutting that back will help. So yeah, we're going to snip the end off, and then we'll check it's deep enough for the terminals. Might need to cut it back a little bit more, but yeah, that's kind of what I tend to do there. So there we go. Snip all these off, and then we're going to get these into the Nest, or into the heat link. And now in terms of cutting the slack back, and cutting the right amount back, it's a little bit tricky with this, because with the heat link, you'll notice that there's not much wiring space in this sort of way. But what I've done is I've realised there's quite a lot of depth to this. There's a lot of space to sort of carefully loop the wires around and then get them in. So what I'm going to do is, first of all, close the box of ferrules, because if you knock one of those over and it's open, it's a disaster. But I'm going to try and carefully get these wires in with a bit of slack on them, and then get them all looped up and in. Because I don't really like the idea of having them cut super short to fit so they go straight. I'd rather have them loop around and have a little bit of slack in here. But the key thing you want to do when you're doing this is make sure that you get the sort of outer insulation inside that cord grip. What you don't want to see is what so many people do when they install these, is install it like that and leaves the inner cores hanging out the bottom of the heat link, because that's not compliant with regulations. And if that you did then get to see an inspection done, it would fail that inspection and then it would need to get sorted. So yeah, make sure you get that white insulation inside the cord grip. So when the heat link's sealed up, all you see outside of the heat link is just that white insulation, and you don't see any of these inner cores. And then make sure the cord grip's gripping it tightly as well, so you can't just pull it and then they pop out. So yeah, that's what we do there. So yeah, we just need to get these wired in. So yeah, I'll go do that off camera because there's no way I can do that here, do that on camera, and then we'll come back. Because yeah, in terms of a placement for the heat link, it's kind of stuffed right in the corner there. Unfortunately, my boiler's boxed in, so I don't really have much scope really to put it somewhere nice. It won't fit in this gap here, it's too wide. And then really under here, it would just about fit here, but then it sits right up against this hot pipe that I didn't want. So I thought I'll put it in the corner there, keeps it out of the way, keeps it away from some major sources of heat. And it also means, because it's off to the side, if there was a leak from under the boiler, it's unlikely to hit this sort of area here, because this is obviously quite expensive if it got wet. So we'll keep it out there out of the way, but it just means that I'll have to sort of squeeze into the corner to work on it. So it's easy enough for me to work on my own, but trying to fit in with a camera without blocking the lighting is not very good. So yeah. So yeah, we just need to get this wired in, and then we should be good for on-off control. So we'll get that wired in and get it set up. Okay, so that's all wired. So it's all pretty neat. And these ferrules are definitely super useful for this, because the way this works is you've got a hole in the plastic and then the terminal's a bit further behind that. So it'd be very easy, especially if you're trying to put it in a funny angle when you're crouching down like this, it'd be very easy to push the flex in and have, say, one of the wires, you know, miss the terminal, because it can go through this bit of plastic fine, but then splay out inside there. So putting these ferrules in makes a really neat finish, makes me a lot more confident these are all definitely in correctly. As for the length, as I mentioned, I'm going to leave a little bit of extra slack, so I've just swooped it around here and then swooped it around here. Doing that just means there's a lot of extra slack. If I ever need to take these out again or move them around, I can easily enough do that. If I cut these to exact length, like I see a lot of people doing, and have them come vertically straight up into the appropriate terminals, there's just no wiggle room. So yeah, that's all swooped around in there. Takes up a bit more space, but there's plenty of room in this. And that cord grip holds that flex really tightly, so there's no way that's going to pull out. So yeah, that's kind of how you want it to ultimately look. The other thing I didn't mention before is I've also sleeved up the switch contacts brown. I don't really know how required this is for heating stuff, and I'd be interested to see what people's thoughts are, because for traditional stuff like, say, light switches and stuff like that, if it's you need to sleeve the conductors up. So if it's like carrying live, you sleeve it brown. If it's carrying neutral, you sleeve it blue. With heating, I don't see it done as much, because you're always using multi-core cables, and I think it's always expected that stuff's switched live and stuff, but I always like to sleeve it up. So I'll sleeve them up brown just to indicate that they are live, because they are switched live contacts. And if you're doing that, put that on before you put the ferrule on, or you're going to have to take the ferrule off and do it again, because that won't fit over a ferrule. But yeah, that's it there. And I'm pretty happy with the end result. And as I mentioned, I can't find much information about whether you need the earth on this if you're not connecting T1 and T2 to a thermostat. So I'll leave that up to you to figure out if you really need it. I can't, because it's cut off in here, but I will ultimately connect the earth later on when I connect the thermostat up, so that'll happen later. But yeah, that's basic wiring that we'll need for on-off control. So yeah, that's all connected there. The only thing I would say is these holes are stupidly tight for a screwdriver. So using like a normal VDE screwdriver like this, they're Phillips 1 screws as far as I can tell, but using a normal sort of screwdriver like this, it just doesn't fit. It's not even the insulation, it's just the head is too big to fit in that hole. And then even using just like a normal uninsulated screwdriver, that was too big as well. And it was kind of risky, because it got to the point that you'd feel it was tightening up, and then the wire would kind of be pulling, wouldn't pull out, but it still wasn't fully tightened. So I had to actually resort to using this like interchangeable bit precision screwdriver to have something that's got a small enough head to get in there to actually hit the screw and not hit this plastic. So yeah, if you're fitting one of these, make sure you've got a very thin screwdriver like this. I mean, ideally an insulated one, but you're going to need something with a very, very thin tip. A traditional screwdriver is going to be too thick to fit through that hole. That's a really stupid design. But yeah, now that's all wired up and I've got the spur and everything put back together. We can now try powering this up and see if the heat link works. So yeah, now we can just put the top on and screw it in. So that's it in there. And this brings up one important thing to remember, is when you're installing this, make sure there's enough space below it to fit a screwdriver in. I can't fit the screwdriver itself, but at least the bit out of it fits, so that's enough. And obviously a small screwdriver would fit in there fine, because you need to leave enough space to get into that screw and do it up. It would be very easy to mount this super low down when you've got the top off it, screw it to the wall, and only at the end, go to put the top on, realise you can't get into that screw. So yeah, make sure you leave enough space there, because I've seen people do it. People mess it up all the time. I've seen so many installs but there's no space to get a screwdriver in, so yeah, make sure you leave enough space there. But yeah, now that's there, we can turn it on. So I'm going to just live on camera so you can see for the first time, see if it blows up and watch it. Obviously, in between doing this and filming the section, I've turned the circuit breaker back on. It has been off for the duration of this. But if we turn the spur on, okay, the boiler's fired up. And in theory, yep, the heat link has a white light on it. Or blue, whatever colour that is, blue light. So that's there. So what I now need to do is get the thermostat set up. So as I mentioned, I'll be wiring it and hardwiring it later. So what we'll do now is we'll get that base out, wire the thermostat up on the base, plug it in, and set this up. So now we have the heat link powered up, let's assemble the stand. So here's the stand here, and basically what you've got is the stand. You need to use the original base that comes with the Nest itself, USB cable, power cable, or power brick, the thermostat itself, and then it comes with 2 screws to mount the base to the stand. There was 2 screws, I managed to drop one down the hole behind the boiler and it's disappeared to literally, it's just gone. Pulled the plinth off, can't find it, I think it's gone through the hole in the floor, the gas pipe comes up, so I've only got 1 screw now, but hopefully that'll be enough. Oops. So yeah, other bit of advice, if you're working underneath a boiler and you've got a big space like that goes to basically under the floor, don't drop screws down there, be very careful. So yeah, now we can assemble this. So there's a film on the bottom of this we can take off, and then what we'll need to do is take the USB cable and feed it up inside that. So undo this. It all feels like really nice quality. It feels really nicely built, which is good. Very nice USB cable. Take that there, pretty long as well. So then that is the USB cable. So we want to take that cable and feed it up inside there, and plug that into the back of the base. So there's a USB port there, so we want to plug it into there like that. Yeah. Yep, so that plugs in there. And then feed that through there and kind of clip it all in so that clips into the base, and then take the cable and just feed it out the back. Now that's done, what we need to do is screw the base onto the stand using the single screw that I have left, but obviously you'd have 2 because you're probably not an idiot who would drop it in the back of the boiler. So that screw goes in there. It still feels pretty secure with only 1 screw, thankfully. That goes through there, flick that cable push into the bottom, and all we now need to do is mount the Nest to this. So the Nest will just simply clip on with that connector on the back, so you just need to line it up and it clips on. So that's on the base. Looks pretty neat. I think I'd prefer it to be a bit taller. It looks a little bit, I don't know, squat and short down there, but that's fine. So that's that. And now in theory, if we plug this in, it should power up. And I presume it just sees the heat link automatically and just sets itself up. So take that brick there, plug it into the wall, and this will be the first ever switch on, so it'll be interesting to see what happens. So that's the Nest there. Let's turn it on and see what happens. There's a little light blinking at the top there. Yep, there's a little house come on, so it seems to be starting up anyway. So we will zoom into this and see what happens, because I think this is the point where we need to do the initial setup. And there we go, that's the setup wizard come up. So we can go through this. I'll do it on camera in case it's useful for people. I'll peel the film off once it's on the wall. So yeah, rotate the outside. English, there we go. For the language, yep. Internet connection, I'll need to set that up now. Actually, I'll skip that for now. We'll set that up later just to do that off camera because that'll be a faff. That location. Europe. UK. Right, I'll put the postcode in off camera. Okay, so I've put the postcode in. Now we've got this, so single family. Thermostat location is hallway. Presume, yep, hallway, there we go. Set a date and time. Oh, I should have connected to the internet, that would have made more sense. Alright, I'll do this and I'll need to come back. Yeah, maybe don't skip the internet setup because now we need to manually set the date and time, whereas if it was on the internet, it would just do that automatically. So I'll go and do this and then I'll come back. Okay, so I've set the date and time. Yeah, probably set the internet up immediately because then you'll get the date time set automatically, but now this is where it gets interesting, so it's equipment. So, do I want to set up Nest Pro? No. This is if you're a professional installer. I think the installer can basically enter their ID that they register with Nest in this, and it'll show their details up as the person who installed it for like future service. Obviously I'm not a Nest Pro, so I can just skip that step. Heat link connected, cool, it's done that. And then we need to pick the type of sort of system we have. So this will vary depending on what you've connected it up to. So I'll go through what I have. So I've got a combi boiler. I'm currently using on-off control. This is where if you wanted to use OpenTherm, you would set OpenTherm here. I'm doing on-off control for now, and later I'll switch it over to OpenTherm. So if you follow the OpenTherm instructions that I show, you just set OpenTherm here from the start. We'll leave that on-off for now. Gas, and it is delivered through radiators. So yeah, that's it there. And continue. So your system, combi boiler, heat with on-off, cool, continue. Temperature. Yeah, that's fine. So this is when we pick the eco temperature, which I think is the temperature from away from home. I'm just going to leave this sort of stuff on default for now, and I'll change it all later. I don't want to really spend too long setting this all up on camera. I just want to get it working, and then I'll go away and play with settings afterwards. Nest app, so I need to connect to the app, so I need to do that just now. I'll get it connected off camera, and I'll come back once that's done. So there we go. That's all set up for on-off control, and it's working. And while yes, we're probably very far into the video now because I know how long my videos tend to be, that was a very simple process. To do this start to finish, you probably do it in under half an hour. So yeah, dead simple to get it set up for on-off control. However, as I've alluded to, I don't really want on-off control with my setup. With on-off control as we have here, all the Nest can do is turn the boiler on and off. So if the room's too cold, it turns the boiler on. If the room's too hot, it turns the boiler off. And then for the temperature of the water that goes into the radiator, that's just set by the boiler. So as you can see on the boiler currently, it's set to 60 degrees. So whenever the boiler turns on, the boiler will heat the radiators up to 60 degrees. And now that's a bit of a problem. It's not a problem, but it can be improved. With this sort of setup here, all you can do is set the temperature of the radiator water on the boiler itself. If you set that too low, what that means is when you try and heat the room up quickly, say you've been out for a while and the room's really cold or it's heating it up in the morning, it'll take ages to get up to temperature. On the other hand, if you set this up to a really high temperature, it'll heat up really quickly, but what that then means is that anytime the room needs heated up just a little bit to maintain the temperature, you're going to overshoot, heat up too hot, then have to wait for it to cool down again, and you'll really notice those fluctuations in the room. The other problem with this is in terms of efficiency. I won't go into too much detail because Urban Plumbers did a much better video on this, so I'll link that. But with a condensing boiler, which this is, and basically most modern boilers, well, all modern boilers are, if you've had a boiler since 2005, it will be a condensing boiler, basically. The way a condensing boiler works is the water going back to the boiler needs to be below a certain temperature for it to condense. And when that water condenses, extra heat can be extracted from the water. If your flow temperature is too high, what happens is the water will go around your radiators, won't be able to dissipate enough heat into the room, so by the time it comes back to the boiler, it'll be too hot, and then it won't condense. And as soon as you do that, all you're doing is just pumping heat out the flue and wasting energy. So you're much better having a lower flow temperature so that the return temperature coming back to the boiler is as cold as possible to allow it to condense and be most efficient. But Urban Plumbers did a much better video on that, so yeah, watch that video if you're interested in this. Another benefit of having the radiators at a lower temperature is you don't have that overshoot problem I mentioned. So rather than having the radiators heat up super quickly, heat the room up way beyond the set point, have it turned off again, wait for the room to cool down again, and then have them heat up, and then when it reaches below the set point again, have the radiators heat the room up way above the set point again, and having that huge temperature fluctuation you've possibly noticed before. Instead, the radiators will run at a much lower temperature and they'll run for longer. So the boiler will be running at a lower power level, so it won't be using as much gas as it would be using it at full power. So you're not really wasting energy by running the radiators for longer, but it just means that you'll have that much more consistent temperature, which is just a much nicer environment to be in. A final benefit of that is just in terms of apparently wear and tear on the boiler. It's not something I can really sort of speak for in terms of experience, but it's what people seem to have said, is because the boiler is not turning on and off as much, it's not heating up and cooling down as much because it's running for longer and at a lower temperature, the parts in the boiler can last a bit longer, so that's always a good thing as well. But the question is, how do we do this? Because, well, you can't be expected to run in here and change the temperature on the boiler every time you want it to, change slightly. That's where OpenTherm comes in. So with what we have here is just on-off control. So as I mentioned, all the Nest can do is turn the boiler on and off. Instead, with OpenTherm, we connect the heat link to the boiler with a digital connection. And that way, the Nest and the boiler can actually properly talk to each other and share details. So what that means, essentially, is that if the room's really cold and the Nest needs to heat it, and I want to heat it up really quickly, the Nest will say to the boiler, right, you need to heat this room up a lot, therefore turn on at full power and heat the radiators up really high. Then as the room's starting to approach the set point temperature, the Nest can say to the boiler, right, you're getting there, just turn your power down a little bit, start easing the power down, and the boiler will slowly lower its power level. And that means it'll almost meet the set temperature rather than overshooting it and then having to go, and then the Nest have to go quick, turn off. It'll just let the boiler sort of slowly ease its power level down. And then once the room's at the required temperature, the Nest can tell the boiler, right, just run at a really low level, just keep a really cool temperature in the radiators, just run it nice and low, and then it'll just maintain the temperature in the room rather than having to turn on and off. Now your boiler still might turn on and off. Not all boilers have very good modulation ratios, so not all boilers can turn down that low enough to fully just heat the property continuously at their lowest power level. This one's pretty good. It can modulate down to I think 3.6 kilowatts or so. Don't quote me on that exact figure. I think it's a 1:8 turn down ratio, so it can turn down pretty low for a relatively affordable combi boiler. So not all can do that, but so it might still turn on and off a little bit, but not nearly as much. So yeah, that's the benefit of OpenTherm, which is what we're going to do. It lets the Nest talk to the boiler more directly and allows the Nest to dynamically adjust the temperature of the water in the radiators based on the temperature in the room. It's called load compensation. So yeah, that'll be really good. So hopefully it'll save a little bit of energy based on the efficiency of colder return temperatures and stuff. But realistically with this, I'm also just excited to have a more consistent, comfortable temperature. Whereas my old system constantly fluctuated up and down, and you could almost you'd be sitting in a room with the heating on and go, oh, I'm nice and warm, oh, I'm a bit too hot, and then you'd be freezing again. You'd actually notice that swing in temperature. So yeah, really excited to try this out. So yeah, now we need to talk about how we connect OpenTherm up to the Nest. So next up, let's talk about how you connect your boiler over OpenTherm. So the first thing you need to do is work out if your boiler actually supports OpenTherm. It's been out a long time, but not all boilers support it. I'd say most new boilers support it, but then you get some brands like Valent that use their own proprietary protocols, and then there's weird things around that. Check your boiler supports OpenTherm basically. And then when you're connecting OpenTherm up to a boiler, essentially all OpenTherm is two wires. Inside your boiler you'll have a pair of terminals labelled probably OT1 and OT2 or just OT or OpenTherm or something. Check your boiler's manual, and all you'll need to do is connect a pair of wires onto that and connect that up to the heat link. And likewise on the heat link, there's a pair of terminals, OT1 and OT2 here, that you connect the OpenTherm connections to. And OpenTherm isn't polarised, so you can connect the wires either way around, it doesn't really matter. Now this is where I'll need to kind of be a bit boring and talk about sort of potential safety regulations and where it's a little bit vague, is removing the front of a boiler to access the electrical connections. And it'd be interesting to see people's comments on this, because some people are like, oh my god, if you open the front of a boiler you'll die and kill someone and be thrown in jail. Other people are like, yeah, it's fine, whatever, as long as it's your own boiler, you're not doing it for a customer. It's a bit vague. Now it also depends on the type of boiler. Some boilers are really good where they have a separate panel that can come off to access just the electrical connections, and they don't open any sort of ceiling. On the other hand, with this boiler here, the front panel also has the room seal around it. So while that doesn't necessarily seal the combustion chamber, that's a separate part of it, the seal behind this front panel does actually seal the boiler, the internals of the boiler, from the room. So that seal is somewhat important in preventing gases coming into the room if there was a fault to develop inside the boiler and the gas is released into the boiler casing itself. So to me, potentially it feels like I think you would potentially need to be gas safe registered to officially remove the front of one of these. So if you have a boiler like that, the best advice I'm going to give, just because obviously I need to be above board on YouTube, is get someone in to do it. It doesn't take long, just get someone to come in and connect the OpenTherm terminals to the inside of the boiler. You know, we won't get into what would happen potentially if you tripped holding a screwdriver and the front accidentally fell off the boiler, but you know, officially, to be above board, you may have to get someone in to connect the OpenTherm connections inside your boiler if the front of your boiler acts as some sort of seal. On the other hand, if your boiler is the type where the front panel is not any sort of room seal, you could actually take that off and connect on, but you really need to look into your particular boiler. Now with my particular setup here, I actually spotted the guy when he was connecting up with the original programmer and realised he was connecting it up for on-off control. So I actually came sort of running through like an idiot and went, oh, OpenTherm, what about OpenTherm? And he wasn't really going to connect up for OpenTherm, I don't think he'd really dealt with OpenTherm before. But what I was able to do is ask him to connect this flex onto the OpenTherm connections inside my boiler. So what the guy's basically done is connected this flex up inside the boiler, and it's connected to the OpenTherm terminals inside it. And then all he's done is just basically, well, I gave him a junction box and a couple of Wagos and just left it like this. So the OpenTherm connection is broken out of my boiler and just disconnected here. So I will then be able to connect this up. So that means I don't need to open front the boiler or anything, I can just connect OpenTherm. But yeah, basically, if you're wanting to connect OpenTherm, your boiler supports it, but there isn't already a cable broken out of your boiler, you know, it's just broken out for on-off control and there's no OpenTherm cable coming out of the boiler. You would need to really see whether you can actually open your particular boiler, connect that yourself, or if you need to get someone in to connect it. Of course, there's also nothing stopping you connecting it up for on-off control for now, and then next time you've got someone in, say, servicing the boiler, you could just ask them, oh, do you mind connecting up OpenTherm while you're here? So, yeah. But yeah, this is what we have here. This is the OpenTherm connection from the boiler. Now, as you can see, we're wired up for on-off control. Now, with this particular type of boiler, as standard, there's a link from the factory for on-off control. So there's a little plug that plugs in, and there's a wire link that essentially connects where the grey and black wires for on-off control are connected. So as standard, essentially grey and black are connected together by this little plug inside the boiler. And if you want to use on-off control, you remove that link and instead wire the grey and black into that. So as it stands right now, because it's been wired up for on-off control, that link has been removed and it's been replaced with the grey and black wires. So rather than opening the boiler back up and then trying to reinstate that link into that connector, all I'm also going to do is just connect the grey and black wires together down here in a Wago. That will essentially simulate the link being installed inside the boiler, which is required for OpenTherm if you're not using on-off control, and I'll connect OpenTherm up to the Nest heat link. This will obviously vary between boilers, so you very much need to look at your boiler's manual and instructions and work all that out yourself. But yeah, what we're going to do is we're going to simulate having that link in place by just linking the grey and black together, and then we're going to get the OpenTherm connections on. Once we've done that, we'll then need to change the setting on the Nest to tell it to use OpenTherm, and we'll also need to change the setting on the boiler so that the boiler also uses OpenTherm, which on this Viessmann is a slightly terrifying process involving going into commissioning mode, which feels way over the top for changing a setting like that, but we'll take a look at that as well. But the first thing I need to do is get this connected up. Okay, so that's all now connected up. So all I've done is I've linked out those grey and black in that Wago, and then we have the two OpenTherm connections going into OT1 and OT2. And I've also just put a little bit label around them just to label OT. Bit over the top, but it's nice just to have that bit of labelling there. So yep, that's OpenTherm now connected to the boiler. So now what we need to do is turn the boiler on and change it so it's going to use OpenTherm. So as soon as I turn the boiler on, it's probably then going to fire because the call for heat wires are linked together. But then when we actually change the settings to connect to OpenTherm, we should be fine. So we'll turn the boiler on now because it'll take a little second to start up. And if you look at the service manual, what it states is we need to go through these steps here to open up the service menu, go down to B5, which opens the commissioning assistant, and then once we're in there, we should then be able to come over here and set in the commissioning assistant the operating mode, and in the operating mode we can set OpenTherm. So now the boiler's on, it's probably going to end up firing, I think. It's logging a fault. I think that's probably connected to the OpenTherm control, which isn't then enabled for OpenTherm or something. It's done that before when I've played with it. But what we now need to do is open up the commissioning assistant. So to do that, I've lost the page. Great. We need to panic and find the page because the heating's now turning on and it's really hot weather. There we go. Pull down menu and OK simultaneously for 4 seconds. So do that. That's fine, there's an error, that's okay. And then we're going to go to B5, which is the commissioning assistant, which is that there. And then we press OK. Boiler's now going to turn off, and this will open up the commissioning assistant. So we can now relax here. Now, if we go back to the menu here, we can start the process to change the setting to switch over to OpenTherm. Now, this is where I'm going to put a disclaimer that I should have probably put in a few seconds ago, is obviously this will vary between boilers. This is just what I'm doing on my Viessmann 050. even then, I also don't even know if this is the proper way of doing it. It seems to work based on what changing the OpenTherm setting before, but I can't find any other way to do it without going into the commissioning assistant, but there may be better ways to do this. So do not try this at home unless you're confident you know what you're doing, and if you mess your boiler up, well, you'll have to get someone out potentially to fix it. So yeah, bear that in mind. Alan Hart did a really good video on how to commission this particular boiler and the commissioning wizard on it, so definitely check that out if you need to get more information on it. But yeah, now I'm in the commissioning assistant, we can change that setting. And the thing to bear in mind with this is when you're in the commissioning assistant, the boiler will not leave this until you complete the final step, which is this here. So if you do what I did the first time I tried this, way before I got Nest, just to see how it worked, and open the commissioning assistant, you'll then panic because every time you turn your boiler on, it comes into this and won't work. If you need to get out of the commissioning assistant, what you ultimately need to do is just go to this last step and complete it, and then you'll be able to leave. So we'll take a look at that. So first of all, it comes up AP. It's because there's an installer app, you can do it over Wi-Fi, which we're not going to do. So what I want to do is go through here, pick that, and then I want to press that for 4 seconds. Press the lines for 4 seconds, and that'll put it into configuring the boiler through the boiler, not the app. So now I've done that, now we're in the commissioning assistant. So we can see that what we want is to change the operating mode to C, which is C7. So we're going to go down here to C7. We're going to hit OK. As you can see, that's currently set to 13. 13 is constant operation with optional room thermostat. We want to change that to 14, which is OpenTherm. There, like that. And we're going to press OK. And it does this weird thing, and then says END, end. Okay, so that's saying end, but it's only got 2-segment display. Great. And then now we're going to confirm that with OK. And that will reboot the boiler. Now, this is something to bear in mind, is that as I mentioned, if you open the commissioning mode, even if you don't want to change any settings, you can't really get out of it. Even restarting the boiler puts it back into this mode. So what you need to do is go to the last option in the menu. In my case, it was C7 for the operating mode, but depending on other things in your system, you might have C8 and C9. Basically, go into the last option, then press OK. It'll say EN or END, and then press OK again, and the boiler will restart. So that's how you get out of commissioning mode. You go to the last option and just basically OK it out. You don't need to change it, just press OK. But yeah, that's now OpenTherm enabled. And if we look up to the boiler, it's come back on. It's not firing despite that being linked out, which is good. The little fault's gone away, which is nice. And it's doing something different. So this is now displaying a temperature, which seems to be like the radiator temperature, because if we go through, that's the radiator temperature, that's the hot water temperature, pressure, eco mode, and there. But rather than this saying 60 degrees, I think it was set to before for the radiator temperature, it's now saying 29 degrees. And if you notice this, I can't change this, whereas previously, say for hot water, you can go up and down on this and change your hot water temperature. With the change I've made now, I can't change that because that's dynamically being set over OpenTherm. So that's really sweet. So what we'll now need to do is go over to the Nest Thermostat, make sure that's set up for OpenTherm, and then we'll test it out. Okay, so now we're all set up. What I now need to do is tell the Nest that I also want to use OpenTherm to control the boiler. So what we need to do, now obviously if you were setting this up from scratch, you would just set OpenTherm during the initial setup wizard, but because I initially set this up for on-off control, we'll need to change it. So to do that, we click the Nest in and go into the settings menu, like that. And then from here, what we want to do is we want to go through the settings menu and find equipment. So go to equipment, hit that, and as you can see it says combi boiler heat with on/off. So if we go into that, go down to Pro Setup, skip past that disclaimer, you can now pick the boiler. So again, we're going to pick Combi Boiler again, but now we're going to go into Control, and instead of On-Off, we're going to pick OpenTherm. Gas is the same, so we're going to leave it on gas, leave it on radiators, and the final thing you'll see here is supply temperature. Now obviously with the Nest will then be doing the modulating control, so it'll turn the flow temperature up and down depending on the heat required. However, what the supply temperature seems to do is it seems to basically be the maximum temperature that the boiler will put the heating circuit up to. So if we go into this here, we can turn that all the way up to, I think like yeah, 100 degrees. Now, I think this will be limited by the boiler itself, so your boiler itself can say, like, I doubt this boiler would ever go to 100 degrees, so I'm not going to do that. I'll just leave it at 75, which seems sort of reasonable. So your boiler might sort of put a cap on that, but that's basically where you set the maximum temperature you want your hot water to be. So if you set that to a fairly high level, that means that when your room's really cold and you want to heat it up really quickly, the Nest will tell your boiler to go super hot, put a really high flow temperature through the radiators, and bring the temperature up really quickly. Of course, if it doesn't need to heat the room that much, it'll put a lower flow temperature through. Realistically, the time I could really see you wanting to reduce this is more of a safety thing. If you've got children or pets that might go up and touch a radiator and burn themselves, or if you're just like me and you're a bit of an idiot and you burn yourself on radiators, you could potentially set this to a lower level. And it just means that even though if you need a lot of heat very quickly, the radiators might not be that hot, so it might not actually heat up that quickly. What it does then mean is the radiators will be cooler to touch, so you're less likely to have like the safety risk of having a scalding hot radiator. So yeah, I'll leave this at 75 just now and I'll just try and not burn myself. But if you did have that issue where your radiators were getting like dangerously hot, you could set that to a lower level. And we'll hit continue. Next up here, we can set the hot water temperature. Because with OpenTherm enabled, you now no longer set the hot water temperature on the boiler. So we can go into this and we can change this. So I have 55 degrees, that's what it says is an eco temperature. You can turn it up higher. I find that 50 degrees is more than enough for me, so I'll set it down to that. You just again need to play about with this. If you find your hot water isn't hot enough or your shower isn't getting powerful enough or getting hot enough, you can turn that up, but I'll set that to 50 degrees because that's perfectly fine for the stuff I do. So we'll leave that on 50 degrees there. And this is the nice thing with using the Nest over OpenTherm, is you can set your hot water temperature through your Nest and through the app rather than having to do it on the boiler itself. So hit continue. Now you can see combi boiler, heat with OpenTherm, hot water at 50 degrees. So hit continue to that, hit done, and we can go right back out the menu, back to here. And that's us now using OpenTherm. So now what should happen, don't know if you'll hear it on camera, but if I turn this temperature up, we should see that the heating should turn on. Click, yep, that's it turned on. So yeah, it's working. So boiler heating's turned on, and then heating's turned off. So yeah, that's pretty good. So that's it working. Now the other final thing I want to quickly take a look at is check that True Radiant's enabled. This is basically what Nest calls their sort of modulating control. So it's under Nest Sense, you can go into here, and you can see we have True Radiant, and yeah, that's enabled. This is the feature that you need to enable to have modulating controls working. It says in the documentation that if you don't have True Radiant enabled, it'll just do on-off control even over OpenTherm, so make sure you've got True Radiant enabled as well. But with that all enabled, we can go out of that, go back there. Now we have OpenTherm working. Now let's take a quick demonstration to show that the modulating control actually works. So what's really good with my boiler is it has an app, there's a Viessmann app, and it shows all different settings and all the temperatures. So we can actually see what temperature the heating circuit's currently set to. We don't have to just look at the current temperature and wait for it to heat up. This will actually show the temperature it's targeting, trying to heat up to. So what we'll do is, first of all, we'll turn this on to a very low temperature difference. So it's currently 24 degrees in here. We'll turn it up just to like 24.5. So we're barely asking it to heat up at all. And as we can see there, the Viessmann app is saying that the heating circuit is set to 44 degrees, which isn't very hot at all. So the boiler's firing, as you can see, but it's not setting the radiators to a very hot temperature because it doesn't really need them to be that hot just to increase the temperature such a small amount. So the idea is it'll only heat the radiators up a tiny little bit to 44 degrees, and that's enough just to top the temperature up in the room without hugely overshooting. So yeah, that's the first demonstration there. So we'll turn that off and we'll wait for the app to show it's off. So it's now been a little while and I've let the boiler cool down. I found this boiler, if you turn it straight on after it's been turned up, straight on again after turning it off, it'll sort of not fire the burner for a while until it cools down. So it's been off for a while. So what we'll now do is we'll set this to a much higher temperature and see what temperature the boiler fires at. So we turn the Nest all the way up to 32 degrees, and now we'll take a look at what the app says. Currently says 46 degrees, but if we wait a little second for the boiler to kick in, we should see that because we're trying to heat the room up a much larger amount, the temperature should be much higher. So we'll give the boiler a little second to fire up, because I think when you're doing this it takes a little second to kick in, and then we'll see what temperature it fires at. And there we go, it's been a couple of seconds, and now the boiler has gone up to 75 degrees, which is the maximum we set on Nest. So with that, you can see that the modulating control is working. if we try and increase the temperature just a small amount, it only sets the flow temperature something like low, like 44 degrees. If we're trying to increase the temperature a huge amount, it increases flow temperature to 75 degrees. And obviously it'll kind of work in between there. And what I assume would happen is that as the temperature in the room approaches 32 degrees, it'll start slowly backing off the temperature to just avoid overshooting. So yeah, that's now switched over to OpenTherm. And as you can see, the modulating controls are working. So let's turn that off because I do not want it to be 32 degrees in here. So there we go, that's it working. So now the final thing I need to do is hardwire the thermostat. So I've kind of mentioned this throughout the video, but obviously I've just been using it on the stand for now plugged into the wall. But as I've already got built-in thermostat wiring running through my flat, I can very easily wire the thermostat and have it mounted on the wall, powered for the heat link, with nothing needing plugged in at all, which will be really nice. So I've kind of alluded to how it will work before, but essentially what I need to do is there's a 12 volt output on the heat link, and I need to join it onto the 3-core earth that runs all the way through to the hallway. And that 3-core earth is currently sitting disconnected behind the spur as we saw earlier. So what we need to do is take that spur off, run a bit of flex from behind that spur over into the heat link. I'll also need to introduce an earth into that heat link because, as it said in the manual, you need to connect the earth terminal if you're using T1 and T2 to connect the thermostat. So I'll also bring the earth from the heat link as well. We'll join it onto that 3-core earth, and then we'll mount the heat link and the thermostat in the hallway. So let's go in a bit closer. Well, I've isolated all the power already, so we'll get the fronts off the accessories here, and we'll take a look at how we're going to do it. Now, as soon as I've said that, I know there's people already writing angry comments about how I've mixed band 1 and band 2 circuits. Now, essentially in the UK wiring regulations, a band 1 circuit is like extra low voltage, so things like the 12 volt here or like communications type stuff. And a band 2 circuit is what they would call low voltage, but essentially it's mains voltage. This low voltage is mains voltage. So this stuff here is currently a band 2 circuit, and by introducing that 12 volt wiring, that would be a band 1 circuit. And anytime I've even run like Cat6 in a wall alongside twin and earth, and people have complained that that's mixing band 1 and band 2 circuits. Not really. Now, obviously I'm not an electrician, so don't take what I'm saying as gospel, and if you're doing this, seek professional advice. But my reading of the regulation states that this should be fine because of what I'm doing. So yes, I am mixing a band 1 circuit and a band 2 circuit in the same Patras box. Realistically, this is no different to inside the Nest, because if you look at the Nest here, what you have is band 1 main, or band 2 mains on the left hand side with all the 230 volt switching. Even as far as the relay contact for the hot water, which is right here, that's also mains, band 2. But then OpenTherm, and this is band 1, and it's already mixed inside the same enclosure. So realistically, how's that any different to this here? And then if we actually read the regulations, it clarifies it a bit more. So this is BS 7671 528.1. Again, not an electrician, don't trust what I'm saying. But what it says is, except for one of the following methods is adopted, neither voltage band 2, this is talking about other stuff, a band 1 circuit shall not be contained in the same wiring system as band 2 circuit. But then it provides a list of exceptions. And the first exception there is, every cable or conductor is insulated for the highest voltage present. So my reading of that is that I can mix the two conductors in here as long as the insulation on the cable I use is rated up to the highest voltage present, which would be 230 volts RMS. So because I'm going to be using mains flex for this, that's already rated at 230 volts RMS obviously because it's mains flex, then surely that satisfies that exception to be able to mix them in here. Now what this does seem to me is, obviously don't go using say bell wire, don't use bell wire, don't use Cat5 or something and join it through in here. Or likewise, I probably wouldn't even use bell wire or Cat5 for OpenTherm or the 12 volt at all, because you're having to mix them in this enclosure here, which obviously isn't separated and there's mains in here. So I wouldn't recommend using say bell wire for any of this sort of stuff that's going into the heat link. But because of that exception, and because I am using mains rated flex, I personally don't have an issue joining them through in here. If it was a problem, I could obviously change it. I could probably pull this 3-core earth out and put a junction box inside the wall floating or something so it's not sitting inside this back box. But what I'm going to do is I'll join it all through here, obviously using mains rated flex, that's all insulated to the appropriate voltage. And I'll join it through in the back here, and I'll very clearly label them to make sure it's very obvious that this is 12 volts and not, mains voltage. But looking at other stuff, I've seen plenty of professional electricians on YouTube installing Nest and stuff, And while they've not necessarily done it inside the back of a fuse connection unit, they've run the sort of 12 volts and OpenTherm through wiring centres that have mains voltage wiring in it. It seems very commonly done, but the key thing is they're all using mains voltage flex. So yeah, I'm not too worried about that. Just that I'd do it to stem the angry comments and then I'd have to reply to every comment with the exact same thing. I'll probably still get them, but we'll see. But yeah, that's my plan here. So yeah, what I'm going to do is I'm going to take off this patras here, put this one with the knockout on it, put that one instead, and then run a bit of flex from inside this patras here, through, out of this, out the bottom through a compression gland, and then over to the heat link. Then we'll get it all wired in. So I'll go and do all that off camera, and I'll come back. Okay, so that's all now connected. So obviously I still need to do the other end, but I'll just quickly show what I've done here before I screw everything back. So starting off with the heat link, we can see what we've got is, as you'd expect, I've got a 3-core flex coming in with the earth and the two 12-volt connections going on to the thermostat connections. And I've labelled everything up, so I've sleeved the wires to indicate the 12 volts, and then labelled the cable going in this thermostat 12 volts DC and earth, just to make it very clear. Now, if you follow that cable over here, that then comes up into the flex outlet plate as before. But what I've now done is I've changed that back box, so rather than just being that solid one, which, you know, this sort of brittle type one here, instead it's this malleable box, so that's now got that 220mm knockout on the bottom, and there's a stuffing gland in it. Now, it is absolutely going to bug me that that's now a square cornered box with a round cornered flex outlet plate, so I'll need to try and live with that or replace the box. I don't know. I'm very fussy about things like that, but I've got this square cornered flex outlet plate, but it's just not nearly as nice as that MK one, so I'll try and live with it. But yep, that's on there, and we've got a compression gland at the bottom, so that brings the flex in. Again, label up there. If we take the plate off, we can see what we've done with that flex. The flex literally just comes up through the compression gland, out into the wall, and then runs over to the fuse connection unit. And then in here, that flex comes up, and it's joined onto the 3-core earth that goes to the thermostat in the hall. So the blue's joined onto the black, the brown's joined onto the brown, and I've just very clearly labelled them up. So even though I'm probably only going to be the person working on this in the future, if say I had someone servicing the boiler and they took this off for some reason, that should hopefully be very obvious enough as to what those are and not to connect them to the mains. So they should just tuck up neatly in the back there. The earth out that flex then connects into this waggle carrying all the earths, so that'll put that earth in, which I think is needed for interference suppression. And then the grey core out the 3-core earth is just sort of coiled up at the back. It probably doesn't really matter what colours you use. The reason I just use these two is purely because at the thermostat end the grey is cut quite short, so I'd rather use the ones that are longer at the thermostat end. So yeah, that's what I've done there. So yep, that's all now connected up at this end, so time to screw everything back, and I'll sort the thermostat in the hallway. Okay, so that's all screwed back, and I think that looks pretty neat. So spurs on there, that's the two flexes, so the boiler supply comes out the flex outlet, the thermostat supply goes into that stuffing gland, they loop up over there behind the boiler, and over there we have the heat link with all the individually labelled cables going into it. So yeah, I'm pretty happy with how this looks. So yeah, I think that's neat enough there. So what we now need to do is go and mount the thermostat in the hallway. Okay, so here we are in the hallway where my old thermostat was. And of course this might vary depending on what you have. You might just have, more than likely you'll just have some wire sticking out the wall and you won't have a back box like this. In which case you can probably just mount the Nest sort of plate over that and mount your Nest straight to it. Now in my case I've got this back box, which is for my old thermostat. And while I could probably take this out and fill the wall and then either mount the thermostat to the filled bit or mount it above or below or something, I'd rather just mount it to this, to be honest. It makes it much easier. So yeah, that's what I'm going to do. Now for this, obviously, you have the Nest base that you need to mount, and while it does thankfully have the same spacing for the screws as a UK back box, so that you can actually mount to it, it's, you know, round and that's square, so that's not going to work. So Nest provide the trim plate, and that'll work for this. So what you can do is you can take the trim plate, you can mount your base to it, and you can screw this to the wall. So this will also screw onto the back box. That's not just what this is designed for though. Say you had a bigger, larger thermostat and, you know, you'd repainted the room or someone had repainted and painted round it, not behind it. This can be quite a good solution because you can stick that over it. It gives a nice big plate that'll cover up really any damage from a previous thermostat. However, for this, while it will work, I've come up with a much nicer looking solution. So first of all, what I'll do is I'll mount this as is and put the thermostat on it. I won't wire it in. I'll just mount it just to let you see what the trim plate looks like. And then I'll show you my solution that I think is a much nicer option and can be really good if you're trying to mount a thermostat on a Nest thermostat onto a back box. So yeah, we'll get this mounted and we'll take a look at it. So there we go, that's the trim plate mounted. So all we need to do is take the thermostat, align the connector on the back against this, and just clip it on. Like that. And that's mounted. So that's what it looks like with a trim plate. And you know, this definitely looks a lot better than if you had a big unpainted bit or loads of screw holes or something. But what you'll see here is obviously I've got a huge amount of plastic around it that isn't really needed because the back box is only just in the middle. So while that does look absolutely fine, and it's definitely a lot better than many other ways of doing it, it looks a little bit retrofitty and it looks a bit cheap with this big bit of plastic. But I've come up with a much nicer solution. So my first plan with this was just to mount it onto some sort of blanking plate. So screw a blanking plate to the wall, drill a hole in the front of it, and then mount the Nest base to that. So I was looking at that and thought, yeah, that would work. But then in digging through various electrical accessories I had, I found a Euro module faceplate, which you've seen in many of my videos. This is what you clip network modules into, or, you know, basically all sort of multimedia modules can clip into that, usually used for networking, and it gives you the faceplate on the wall. So I took this and realised that the Nest base actually covers the entire cutout in it. So this essentially has a big cutout in it. So what you could do is you could screw that to the back box, and well, put that against the back box, put the Nest base on it, screw through both of them, and mount that on the wall. And then it basically does the exact same thing, but rather than the base here, it's just significantly smaller. Now, if you're using plastic ones like this, I would be a bit careful with the profile, because with the Nest base, because ones like this that curve quite considerably, you end up with a gap where the Nest base goes flat and then the faceplate curves away from it, so this sort of style doesn't work very well. This style here is a bit better because it's beveled, so it still looks a bit nicer than having a properly square one, but the Nest doesn't cover up the bevel, so it sits a bit more neatly on the front. And I found that works quite well. But of course, using that, it does still stick a bit further out from the wall because it's beveled. It's a similar idea to this, really, but it's not the nicest solution. So the solution I've come up with is these. So these are flat plate metal Euro module faceplates, and I think these will look absolutely amazing because they're so thin, they will sit perfectly flush against the wall. Now, you can get all different finishes of these as well, which is the other benefit. Because I've got a pure white wall, I'm just going to go for a pure white faceplate because it'll blend in really neatly. Annoyingly, the white ones are actually relatively hard to get or a bit more expensive because not like the cheaper brands like BG and Knightsbridge don't do white flat plate for some reason. They tend to do white screwless stuff. So I had to get the MK Edge one, which was like 20 quid, so that was great. I know Schneider do white flat plate, but they tend to put the logo in the corner, which might not look as good. And I think Hamilton, their shear line, has a lot of different finishes, including white, which is good. But yeah, I'll be using white, but the benefit is you can get all different finishes. So say, for example, you've got a more colourful wall, say a dark blue wall or something. White would probably look a bit silly, but also so with this trim plate. But you can maybe use like a stainless steel one. That would also match the stainless steel in your Nest. And that might look a bit better against a painted wall. You can also get matte black ones, you can get gloss black ones, you can get brass, you can get copper coloured ones. Especially the Hamilton shear line, you get all different finishes and different darknesses of brass type things and different brushing patterns and stuff. So this could be a really good way of doing it because you can put that behind it and almost pick something that complements your wall rather than this, it's just a big white bit plastic. But yeah, so on mine I'm just going to use this white one just because it's a white wall, but the benefit of using these flat plate ones is you can get all different types of finishes. So what we'll now do is we'll whip this off, put this on instead, and we'll take a look and see what looks better, because I think this will probably look a little bit better than that. Okay, so let's get this mounted. So we've got all the wires into this Wago at the back now. That just keeps them out of the way because this cable wasn't being used, so we'll take them all out of there. And then I'll just put the grey into a two-way Wago just to keep it out of the way because we're not using the grey. You can see why I'm using the other two because the grey is quite a bit shorter than those, so I thought, well, I'll use the longer one so I'm not cutting off more and more slack. So put that into a Wago there. And then we can just tuck that into the back. And that leaves these two wires here, which will just pull through the faceplate. So what I now need to do is mount the faceplate. So it's a little bit fiddlier than using the trim plate, because the trim plate had the benefit that you clip this into the trim plate and then the whole assembly was screwed to the wall in one go. Whereas because you're kind of screwing through these two, they can kind of rotate independently of each other. So what I find is easiest is just to sort of lay them flat like that and then drop the screws through. And that way the screws will kind of help keep at least the two parts roughly together. So we do that there and you get that there. So then that's like that. Now all we need to do is take this here and screw it to the wall. So if we can get that screw through there, lightly tighten it, get the other screw to the other side, and also lightly tighten it up. But then go and tighten this up. I'll get a spirit level so we can level it, and then we get this on the wall. Okay, so we can now screw this back. Get it back on the wall. And it's a little bit fiddlier than the trim plate, but it's not too bad. And given how much nicer this looks, I would definitely do this over that trim plate any day. At least if you're mounting onto a back box, obviously. If you've got a damaged area of the wall, then yeah, the trim plate does make sense. So we'll tighten up sort of part way. And then what we'll need to do is level the Euromodule plate first of all. And then once that's leveled, then independently I'll level the nest using the little spirit level that's on it. So do that, get that roughly level, and that's level there. I don't know why I'm faffing so much making something round level, but anyway. Now that's done, we can then tighten up these screws and watch it shift off. It's a little bit fiddly, but once that's done there, that's now looking pretty level. So what we now need to do is take the Nest Thermostat, which is here, and put it on. So take that. Actually, connect the wires first, what I'm doing. Okay, so let's get these wires connected. Now, as it mentions in the manual, I think I mentioned earlier, these aren't polarized, so it doesn't matter which way around you do them. But just for consistency, I use brown on T1 at the heat link, so I'll use brown here as well. So we'll just put that into T1. Also label these up 12 volts, even though it's probably not a big deal because there's nothing mixed up in here, but just make it very obvious for anyone in the future that this is not mains. So put that into there. And then likewise for the black, we're just going to put black one into T2. And that will then give us the 12 volts that we need for the thermostat. So stick that into there. Screw that in. And that's now both securely in there. So now the wiring's done, we're going to put the Nest thermostat on for the first time and see what it looks like. So take the thermostat, line it up correctly, and in theory that should just clip on. There we go. And that's what it looks like. So in my mind that looks so much neater than the trim plate, and almost looks just as good as it would be, say, if it was just perfectly mounted on the wall. So if we go out a bit further, I'm so happy with how that looks. I think it's still squint, I'll adjust it later. But that looks really neat. And yeah, that looks so much better than that trim plate. And to be honest, I don't really see an issue with how, I don't almost see a reason to even try and patch that wall, because that looks so neat like that, and then gives the back box behind it to access the wiring and keep the wiring out of the wall void and stuff. That looks pretty good. So yeah, that's all neatly mounted on the wall there. Okay, so I'm going to turn the spur on at the boiler. So now in theory, if I turn the heating circuit on, this should power up. So let's see if this works the first time. Okay, the boiler turning on, and you can see a little light blinking on the top of that, so that's indicating it's, I think, starting up. I think I did this before when I had it on the plug-in base. And there we go, the thermostat's working. So that shows that the 12 volt connection is actually working. So yeah, that's it running there. Okay, so that's it all now installed. Now after setting this up, there's one more thing that I found that's a little bit weird. Now I talked about this in my boiler video, but it's about a feature that lots of combi boilers have called hot water preheat. And essentially what it is with a combi boiler, if you've got one you might even notice it, that periodically it'll just turn itself on for a few seconds really, run the burner, and the idea is just to heat the heat exchanger up and keep the heat exchanger hot. The only reason it does that is when you turn your hot tap on, it's a little bit quicker for the hot water to come out. But because it's a combi, it'll still take a while for the hot water to turn up. You don't get instant hot water. So you still do have to wait a few seconds anyway. Now, of course, having your combi boiler periodically firing up and heating up its heat exchanger will use a bit of energy. It's not much, and I'd be interested to actually try and measure it and see if I can see how much it actually does use. But it will use a little bit of energy unnecessarily. But also, I just don't like the idea of having my boiler just periodically firing up and just, setting its internals on fire periodically just while I'm away from home. Being away from home on holiday for a couple of weeks, knowing that back at home my boiler is just occasionally turning itself on and burning gas. Because if something goes wrong with that and I'm away from home, well, I've got no chance to spot something starting to go wrong with it. So I'd rather it didn't do it. Now in my boiler install video, I disabled that. On the Viessmann boiler, it has a feature called DHW Eco, and if you enable that, it disables the preheat. And sure, it means it takes a little bit longer for hot water to come out, but I can deal with that. and I'd rather that than waste energy. Now, annoyingly, after setting up the Nest and enabling OpenTherm, the boiler's now starting to preheat again. And now the control panel on the front of the boiler doesn't do anything because it's all being managed over OpenTherm from Nest. So I can't even enable DHW Eco Mode anymore. So that means that my boiler is currently preheating, and there's no way on the boiler to turn it off. Nor is there a way that I can really see through Nest. So I think this is maybe a limitation of Nest. There is one little trick I found though that does seem to stop it. Now, this is something that's very unsupported, so I wouldn't recommend doing this unless you're willing to deal with any issues it causes. So this is what I've done. Don't trust me, I'm a bit of an idiot. But what I found is obviously this set up as a combi boiler. Now what you can actually do is you can go into the settings on this, and if you go into settings, go all the way through to equipment, here, where we changed it before, continue, go down to Pro Setup, and press continue again, you can change the type of boiler. So I found if you change this to a system boiler, again leave it on OpenTherm gas radiators, the temperature I want, continue, you can then pick what sort of hot water setup there is, because a system boiler is where you've got a conventional cylinder, where you're going to want to set a schedule on the Nest to heat your hot water. So you can set it to on-off control or OpenTherm for hot water, and that means Nest app will then show you and let you create a schedule for your hot water control, which I don't want. But if you set that to not connected, the Nest will now work essentially for a system boiler with no hot water control. So it won't give you any hot water control on the Nest. But I found that this still works as a combi boiler, the heating still works, the hot water still works, but it no longer preheats because the Nest doesn't think it's connected to a combi boiler. So I found that does work. So we can press done on that, and that's now set up. So this will now not preheat. There is, however, one big disadvantage of doing this, and that is when you've got it set as a system boiler, there is no way to change your hot water temperature. Because obviously that's done through Nest now, not on the front control panel of the boiler, and because Nest now thinks it's connected to a system boiler, not a combi, it no longer gives you the option to set your hot water temperature. However, I have found a way around it, and that is that it does still seem to remember the temperatures it was previously set to. I don't know if that's the Nest or the boiler remembering that, but all it means is if you want to change your hot water temperature, you have to come in here, go to Pro Setup, and basically change it back to combi, go into here, then set your hot water temperature, so I'll put that down to 50 degrees, which is what I wanted. Continue, continue. That'll now update on the boiler, and maybe give it a little while to make sure it's set. And then once that's done, you can go back in and go back and tell it that it's a system boiler again. And I found that that does let me then change the hot water temperature. It's just a bit of a faff because I can't just do it from the app now. I have to come to the thermostat and go through this whole process. But for me, I will gladly take that hassle over having it doing the preheat. So yeah, bit annoying with Nest that there's no way to just disable the hot water preheat through the Nest. That seems like for something that talks about being so eco-friendly, not having a way to disable that's a little bit annoying. But that was a little sort of workaround I found that may work. Now this could cause other issues, so don't take my word for this, but that's how I was able to sort of stop it preheating. Obviously if you did try this and it did cause issues, you would just need to set it back to being a combi boiler again and live with the preheat, but yeah, that was sort of workaround I found there. So there you go, that was a video of installing my Nest. And I'm very happy with how it went. Obviously it's been a very long rambly video, so if you got to the end, well done. But I tried to go into show all the different ways of doing it with OpenTherm on-off control, how to mount the thermostat. So I basically went into every bit of detail possible. So hopefully people found that useful or interesting if you're just watching me install a Nest. So overall I'm very happy with it. Now it's not heating season yet, so I've not really used it other than just turn the heating on to check it works. Later in the year, if I actually find any issues with it or whatever, I'll probably do a follow-up video, but I can't really seem to have any problems with it. But this may feature in a couple of future videos because I'm planning on doing some more smart home integrations with this, so we'll take a look at that. But yeah, very happy with it. And I'd also like to say a massive thank you to Heatable for sending this over for me to install. Obviously they haven't paid me to actually do the video itself, but they have sent me this Nest free of charge to install. So if you're interested in buying a boiler, you can check out the link in the description and use voucher code off your order. And likewise, if you want to install a Nest yourself, I've put links in the description to all the parts used in this video so you can get this installed yourself. So yeah, thank you very much for watching. And stand by for a few future videos where I do more smart home stuff, and some of that will be integrating with this Nest, so that'll be kind of cool. So yeah, stay tuned for that. But yeah, thank you very much for watching.